Good day, everyone. My name is Moses, and we are here in Zigmatech Consult Limited Learning Hub. Today, I'm going to take you on a subject, chemistry, and the topic is matter. I know it's a normal thing you've been hearing from when you are small to date about matter. But there's a misconception that people have in this particular thing called matter. Now, matter is gotten from the word Matthias, that means occupy. In that context, anything that occupies any area is tantamount to be called matter. Now, we know that the first matter that existed was God. God said, heaven is my throne and earth is my footstool. So in that context, he occupied the whole heavens. In essence, he himself is a matter. Now, we had no definition of matter until John Dalton came to play in 1808, telling us the properties, the ways and structure of how matter behaves, or how you can know that this thing is called matter. It has been existent, like I said, but the word matter was not in existence. It was only the meaning that was there. In that context, let's know what matter is. Matter, in this point, matter, as we know, is anything that has mass. And occupies space. Now, we have seen that matter is anything that has mass and occupies space. Now, how do we know that this thing is a matter? What is mass and what is space? Space simply means area. And mass, most people or most textbooks will tell you that mass is quantity. Quantity and mass are two different things. Quantity is the counting of numbers, the collection of numbers. For example, I have 6 eggs. 1, 2, 3, 4, 5, 6. As I'm counting it individually. Me counting it individually means I'm counting it in numbers. In mathematics, it's called integers. 1, 2, 3, 4, 5, and 6. Now, if I collect these eggs together, it gives me 6. Now, this is the quantity. And these are the numbers. Now, when I measure this quantity, let's say it gave me 20 kilograms when I measured it, it becomes the mass. Now, why did we use kilogram in mass? It's because the SI unit for mass is a kilogram. In essence, mass is defined as the measurement of the quantity of matter a material contains. Every single thing you see is a material. That thing you see inside is the matter occupying that space of that material. Now, when that material inside that, when that matter inside that space of the material is being measured, we come to see and we say it is a mass. Now, there are two things that will tell us that this thing is a matter. And those things are called its properties. Properties simply means characteristics. How do I know that this is a matter? What property does this kind of matter have? In human being, we know the characteristics of a living thing, like movement, respiration, irritability, and so on and so forth. That is to say that any object that possesses this thing I said is a human being, is a living thing. That is the same thing you are going to see in matter. That anything that possesses particular thing is a matter. And the properties of matter, are chemical property and physical properties. In essence, there is chemical characteristics and physical characteristics. Now, what is a chemical property? A chemical property are those properties. Chemical properties are those properties associated with chemical changes. Now, it is associated with chemical changes. In essence, it is the main particular thing that you must have to, that the chemical property must have to undergo to tell us that this is a chemical change. What do I mean? Associated means it works together. It is a bond. This is the particular thing that leads us to chemical change. Now, what is a chemical change? A chemical change is a change in matter. It's a change in matter that is irreversible. And new products, and new substances or products are being formed. In essence, if you see any change in matter, if there's a change from one phase to another in matter, and new substances are being formed, and that change cannot go back to its normal form, it is called a chemical change. Let's take for example, hydrogen and oxygen gives us water. Now, some people will tell you this is H2. It is not called H2. It is called H subscript 2. Now, we did mathematics. If I write 3 and 10 like this, you're going to tell me that this is 3 base 10. You will not tell me it is 310. That's the same thing when it comes to a context like this. If I put something like this and I put something like this, they are not the same thing. This one is H2. Why this is H subscript 2. Now, any number, take note, any number at the base of an element represents the number of atoms in that element and is called a subscript. Any number at the base of an element represents the number of atoms in that element and is called a subscript. Now, a subscript is defined as a number that denotes the number of atoms in one molecule of an element. A subscript is defined, or a subscript denotes the number of atoms in one molecule of an element. What am I trying to say? If you have this H2 now, this 2 now represents the number of atoms in this element called hydrogen. Now, I am calling hydrogen a molecule because every element is a molecule, but not all molecules are elements. Every element is a molecule, but not all molecules are elements. As we are going further, I'm going to tell you what a molecule is, and we'll talk about the particles of matter. Now, this is H subscript 2. This plus here means react. It is not H subscript 2 plus O, no. This plus here means react. And this O simply means oxygen. In essence, H subscript 2 reacting with oxygen gave us water. H subscript 2O, that's how you call it. You don't call it H2O. H2O is wrong. Now, if you check this particular reaction, this reaction is giving us a chemical change. Why? Because when these two elements reacted together, they gave us a different product. Inside this water, you're not seeing the oxygen. Inside the water, you're not seeing the hydrogen. You don't even know the amount of hydrogen and the amount of oxygen inside this water. It cannot be denoted. In essence, they gave us a different product altogether. And there is no separation technique, or there is no method that has been known in history that it can make water to go back to hydrogen and oxygen. It can be separated. In essence, a new product has been formed. Now, there's one thing I want to tell you. You check H and O, hydrogen and oxygen give us water. Now, before this water has been formed, every single reaction, for every reaction to be possible, there will be breakage of bonds. What do I mean? Hydrogen will bring his own bond. Oxygen will bring his own. Both of them must have to agree, and will give us a different substance that is called water. For example, we want to cook soup today. You bring a goosey, you bring salt, you bring pepper, you bring everything together. Now the name you're going to call that thing is a goosey soup. In essence, the whole soup is going to taste the whole product you put inside. If I take Exam, the Exam will have a nutrient of the meat. The meat will have a nutrient of the fish. The fish will have a nutrient of the oil. The oil will have a nutrient of the salt. In essence, everything will have the characteristics of what is inside. Now, the breakage of bonds gave us water. Now, coming to physical change. Now, the product formed as a result of this chemical change is called a compound. The product formed, take note, as a result of this chemical change is called a compound. Now, what is a compound? A compound consists of two or more elements chemically combined together. As you can see, there's a chemical combination. That is why it's called a chemical change. MB, take note. Any product that is being formed as a result of chemical change is called a compound. Like I said, a compound consists of two or more elements that are chemically combined together. So many examples are like tetraoxosulfuric acid, where we'll get hydrogen, sulfur, and oxygen. This is a compound because three elements came together. This one is two, and this one is three elements. Now, let's talk about the physical change. Let's talk about the physical property. A physical property is a property that is associated to physical changes. A physical properties are associated with physical changes. Now, what is a physical change? That's another one. You've known that the property characteristics are associated with physical changes. Now, what is the physical change? What's the physical change? We know that physical is tantamount to what you see. What you see, what you touch, what you observe, all those things are physical. Now, this physical change, a physical change is a change in matter that is reversible and no new substance is being formed. The first one says it is irreversible, the chemical change, and this one is telling you it is reversible. Now, let's take for example, we have salt and water. In this physical change, you're going to show us the process it undergoes in giving you the product. Now, what's the process? It gave us a process of mixing, and it gave us salt solution. Now, when dealing with physical changes in an equation, this plus here signifies mixing or and, either and or mixing. Anyone you want to use, you're correct. In essence, salt and water, the process they gave to us was mixing. Mixing, when they say mixing, ing is a process in English language. In essence, the process it gave us was a salt solution. Now, like I said, in physical change, when you want to give us an equation, you must have to place the product being formed and tell us how it can be reversed. How can it be reversed? We got here salt solution again. Now the reversing process, we can reverse it by what? Evaporation. And it will give us salt plus water. Now, if you check this equation, you're going to see that the salt and the water gave us a salt solution. Now, I said no new product is being formed. This salt solution is not a new product. Why? Because when I put the salt and the water, mix it together, I am still seeing the water. It gave us a solution. I am still seeing the water. Now, what is a solution? A solution is the combination of two or more products, of two or more substances, to form a single product. Again, a solution is the combination of two or more substances to form a single product. The two substances that are used in forming this single product are salt and water. And it gave me a salt solution. Like I said, it gave me a single product, which is this. I am seeing only the water inside the cup. The only way I'm going to know that there is salt inside is when I taste it. In essence, the salt and water gave me one single thing, salt solution. Why is it called a solution? Because it combines of two products. Now, I want to reverse and get my salt and water back. That process I use in getting it back is called evaporation. What do I mean? If I put that same water that has that salt solution on the fire, maybe heat, I use heat in getting it, the water is going to evaporate. You can collect the water if you have a distillation process. The water is going to evaporate and the salt will remain inside the pot. In essence, I have separated them and I've gotten my salt and water back. Now, this evaporation process can be used to separate a liquid and a solute. What do I mean? This evaporation process is a technique, is a method, is a separation technique that can be used in separating soluble solids in a liquid. Why do I call it soluble? Soluble solids are called solutes. And a solute is any substance that can dissolve in a solvent completely. That word completely must have to be there. Because even a stone can dissolve in water if kept for years. The particles might be going out bit by bit, but they cannot dissolve in water completely. Now, a salt is a solute because when I put the salt into the water, it dissolves completely. You cannot see the salt anymore. It has mixed with the water. Like I said, a solute is defined as a substance that can dissolve in a solvent completely. Now, what is a solvent? A solvent is any substance that a solute can dissolve in completely. Take note. A solvent is any substance that a solute can dissolve in completely. Now, evaporation in this context, like I said. Now, evaporation with its real definition, evaporation is the breaking down of liquid stroke solvent molecules to gaseous form with or without direct heating. Evaporation is the breaking down of liquid or solvent molecules to gaseous form to gaseous form with or without direct heating. What do I mean? It's either you heat it directly or indirectly. The sun brings its radiation and it hits the earth, and water evaporates and goes to the sky and comes down as rain. Now, the breaking down of liquid to solvent molecules of gaseous to gaseous form with or without direct heating, is called evaporation. Now, evaporation has a law. The law states it occurs at all temperature. It doesn't matter the temperature. Even if it's minus 200 degrees Celsius, evaporation will still occur. Even if it's 600 degrees Celsius, evaporation will occur. In essence, the only difference is that one will be slower than the other, but there must be evaporation. Now, there's something I need to tell you in chemical change. Pardon me, I overlooked it, but it's a very important thing. Now, the substances or the elements used, or the element that partakes, or the element that reacts together to form a compound are called reactants. The elements that react together to form a compound are called reactants in a chemical change. While the substances that come together to form this mixture are called constituents. Now, the product you get in a mixture, which is a salt solution, those products you get as a result of physical change is called a mixture. That product you get as a result of physical change is called a mixture. Like I said, this particular salt solution that we got can still be called what? A mixture. Now, a mixture is defined, as the combination of two or more substances physically combined together. Two or more substances. Now, these two or more substances, like I said, are called constituents. In essence, the salt and the water are called constituents. Now, matter, be it as it may, has states. Matter has categories. I know you've not heard that before, that matter has categories. Matter has states, they have categories, they have particles, and they have classes. In this Zigmatech Learning Hall, we are giving international standard. It is not a standard that is being confined to Nigerian education. What I'm telling you, even if you go to England, it's the same thing you hear. You go to Europe, it's the same thing you hear. Because our people perish for lack of knowledge. Now, like I said, matter has classes. Matter has classes. Matter has categories. It has classes. It has states. And it has particles. Now, from the categories of matter, we know the states of matter. From the state of matter, we know the classes and its particles. Now, first of all, the categories of matter are in three. Matter has three categories. Matter has the physical state of matter. Matter has the man-made state. And they have the natural category. These are the three categories of matter. The three categories of the first one, like I said, we'll talk about the categories of matter. The categories of matter. Now, like I said three categories of matter are the physical, the man-made, and the natural. I know since when you were small till now, they told you matter is 3 states. Matter, we've passed that particular state time where matter has become 3 states. The last state of matter was discovered in 2014 by Payoto Capista, and it's called the superfluid. Now, if your teacher is not upgraded, you cannot be updated. That is why the learning hub, we are always updated. Now, these things I'm going to tell you might not be in your textbook, but they set it in the WEAC. Now, physical state of matter are the gas, the solid, the liquid, and the plasma. The man-made state of matter is called the Bose-Einstein condensate. While the natural states are the superfluid, the superconductor, the photonic molecules, and the quark, gluon plasma. Or you can call it the quark soup. Now, from these categories, we've gotten the states of matter. In essence, the states of matter are 9. Now, the states of matter are gas, solid, liquid, plasma, Bose-Einstein condensate, superfluid, superconductor, photonic molecules, and the coagulant plasma or quark soup. These are the 9 states of matter, and it's been categorized in 3. You can see the category physical, you can see the category man-made, you can see the category natural. Now, what is a solid? Because of time, I am not going to explain the whole 9 states of matter. I'll just speak the 4, the physical states, because of time. Now, we have seen the physical states of matter. Now, we are going to talk about the states of matter. Like I said, we'll talk about the physical states of matter. Number 1 we took is a solid. Now, what is a solid? A solid is any substance that has a definite shape as well as mass and volume. Now, anything that has a definite shape as well as mass and volume, it has a definite volume, definite shape, and definite mass, is tantamount to be called a solid. Now, why does a solid have definite shape? Why does it have a definite mass? Why does it have a definite volume? It's because the molecules in a solid are clumped together. The molecules in a solid are clumped together. They have a bond. They have a magnetic bond that binds them together. In essence, they do not scatter. Their molecules are clinched together. Take, for example, if I tell 8 people to hug themselves, and they hug themselves, it will be difficult for you to separate them. And in that context, they're going to form a shape. And they're going to occupy a particular space or volume. So, why does a solid have this particular shape? It's because their intermolecular forces are strong. They bond together to form this particular shape. Now, there is a law. They have a definite shape, like I said, definite mass and volume. If, let's take for example, this marker weighs 12 kilograms. If I take this marker to London, it's going to weigh 12 kilograms. I take it to America, it's going to be 12 kilograms. If I drop this marker on a table and I travel for 3 years, if I come back, I'll still see it on that table. Except somebody removes it. That is when it's going to be shifted. Now, and like I said, if I drop this marker again on the table, that particular place it occupies, let's say it occupies 15 centimeter cube per area. That's the same place it's going to occupy if you take it to UK. That is why the law is telling us that the law of solid is telling us it is always fixed. It's always fixed in its position. It's always fixed in its position. You know, example of solid: stone, you can say cup, cameras, pot, stove, anything. If you keep your stove there, you will not tell me that you traveled and came back and your stove was shifted, except somebody removes it. That's why I would say it is always fixed in its position. Why? Because its intermolecular bonds are very strong. Take note. Why does a solid have a particular shape, so as mass and volume? Because their intermolecular bond is strong. They have a very strong intermolecular force and bond. Now, the second one we said is a liquid. A liquid is any substance that cannot be compressed. It is an intermediate between a solid and a gas. Why did I say that? When you heat a solid, it changes to liquid. And when you heat a gas, because of condensation, it changes to liquid. Now, anything that you cannot compress, take for example, I put the water inside the sachet and I want to press it. You cannot press it. What's going to happen is that the water will overflow. It cannot be pressed. But a solid can be pressed. When you carry a bread and you compress it. So anything that cannot be compressed is a liquid. And it always conforms to the shape of its container. Why? It does not have a definite shape. If I pour a water on the ground, you will see that the water will be flowing anyhow, shapeless. It is only when it is collected in a container that you can see that it gets a shape. Why? Because it obeys. It is directly proportional to the container it's being put in. And there's a law that binds it. It states that it always conforms to the shape of its container. Now, when heat is added to a liquid, it changes to gas. When the heat is being removed, it changes to solid. That is why I said it is an intermediate. It is in the middle of gas and solid. Now, what is a gas? A gas is any substance. A gas is any substance that when confined, a gas is any substance that when confined expands to fill its container. But when unconfined, escapes vigorously. A gas is any substance that when confined expands to fill its container, but when unconfined, escapes vigorously. What do I mean by confined? Confined means when you cover it, when you take it in the container and close that container, it has been confined. Now, at that process, the gas escapes to fill its container. In essence, as it's escaping, it is compressing. If I put a gas now in a container, as I put that gas in a container, I cover the gas. Remember, the gas will be looking for a way to escape. Now, as it wants to escape, there's no way for it to escape. So it will start heat. Its molecules will start to hit the walls of the gas. In essence, when it hits the wall of the gas, it will come back. So in that context, the molecules that hit themselves come back to hit themselves inside the container. And in that context, they become compressed. Now, when you open the gas, because of their being compressed, they are looking for a way to escape. When that gas is opened, it will escape vigorously. It will escape anyhow. When you're cooking and you cover your pot, take for example, you cook and you cover your pot. Immediately you open your pot, you see how the gas will escape. Why? Because it has been looking for a way to escape for a very long time. Now, that process where the gas is expanding inside that container, it is always been compressed because there's no way for him to go. He's only looking for a space to run. When the pot is being opened, he runs away vigorously. Now, every gas you see that expands in a container, every gas you see that undergoes this confinement is as a result of diffusion. And when you allow that gas to escape from a hole, it becomes effusion. From diffusion, the gas will effuse, and that is the Graham's law. We'll talk about that in our next class or thereabout when we talk about gases. Now, take note. I want to tell you an important thing before I leave. Every gas is a liquid. Every single gas you see is a liquid. Why? Because of condensation. Condensation is defined as the process whereby a gas changes to a liquid phase when heat or when come in contact with a cooler surface. Take note, the gas must have to come in contact with a cooler surface before it can change to a liquid. It must have to come in contact with the cooler surface. When you're cooking, now, and that process where a gas changes to a liquid phase is called change of state in matter. When solid change to liquid, liquid change to gas, gas change to solid, solid change to anyhow, vice versa, that process is called change of state. Because change of state is a process or is a transformation of one state of matter to another. That change of state. Now, like I said, in the condensation is defined as the process whereby a gas changes to liquid phase when come in contact with the cooler surface. When you're cooking your food and you open your pot, remember the first thing you see there is evaporation, gases. But when you look at the cover, or when you place your hand on that vapor that is coming out from your food, what you're going to see are molecules of water. You can still call it particles of water. In that context, the gas has changed to a liquid. Why? Because your hand is cooler than the gas. If your hand has the same temperature with the vapor, that particular condensation will not be possible. So it must have to come in contact with a cooler surface. Now, when this happens, we say condensation has taken place. Take, for example, when the sun hits the sea and there's an evaporation, the water will definitely change to gas because of heat, and it's going to evaporate. Now, when the water hits the cloud, it changes to rain and comes down as water. We did water cycle in school. So, the last one, like I said, is the plasma. That's the physical state. That's the plasma state of matter. The plasma state of matter is a state of matter that is luminous in nature. That state of matter is luminous in nature. It is not a normal state of matter here on earth. It abounds the universe. It is luminous in nature, and at that, it is natural but can still be made artificial. That's the only state of matter that is natural but can still be made artificial. The rest, the physical state, cannot be made natural. The man-made states, which is the Bose-Einstein, cannot be made natural. The natural states of matter, which are the photonic molecule, superfluid, coagulant plasma, and the superconductor, cannot be made physical. It is only the plasmatic state of matter that has these characteristics that it can be made both, it is both natural and physical. Now take, for example, we all know that fire occupies space. What state of matter is fire? Because fire does not rest on the object that is burning. Fire floats. In that context, fire is massless. I want to tell you spirituality in this. Fire is massless. Fire does not have mass. So if fire does not have mass, that means to say matter that has mass and occupies space can be proven wrong. I will tell you spirituality in our next class when it comes to this. There is spirituality on that. So one of the examples of plasma, like I told you, is fire. Fire is massless. There is no measurement of fire. The only thing we can get from fire is the heat. We can measure the heat that comes out of fire. You can measure the pressure, the force, because pressure is force. You can measure heat brings pressure. You can measure the pressure that comes out of the fire. You can measure the heat, but you cannot measure the amount of fire on a particular object because it's floating. Anything that is floating cannot be measured. That is Isaac Newton. So now examples of plasmatic state of matter, we have, like I said, plasmatic state of matter are luminous. In essence, they ignite light on their own. And that is why Jefferson Laboratory said that the stars are superheated balls of plasma. What do I mean? If you look at the star brings out its own light. And that is one of the examples of the plasmatic state of matter. We do not know the mass of the stars. We don't know the mass of fire. Who can tell us the mass of the moon? Who can tell us the mass of the sun? Like I said, it is not a normal state of matter on earth, but it's a normal state of matter in the universe. The only state of matter that I can tell you that is the plasmatic state is fire, like I said. Now, it can be made artificial. How? You have a bulb in your house, or you have a candle in your house. You light your candle, and the whole place will be bright. Now, that particular candle that you lighted was not natural. That light you have in your house, the bulb you put in your house to on your light, was not natural. It was being made artificial. But that bulb became luminous. Why? Because of an electric charge, or because of electricity, or because of the flow of electrons in that wire.